Airplane turbulence, long considered a byproduct of atmospheric instability, may be undergoing a quiet transformation in both cause and character. Meteorologists have measured its statistical rise in recent decades, linking it to jet stream intensification and shifting thermal gradients. Yet these explanations, though physically accurate, may tell only part of the story. An aircraft is not an abstract object moving through a vacuum. It is a living mechanical organism interacting with a world alive in ways we seldom acknowledge. Within that system of interaction, there are subtler, sometimes overlooked contributors to instability that fuse biology, engineering, and entropy into one continuum. Aircraft, when idle or in maintenance, often sit open to the world. Hangars that breathe, cargo bays that invite, vents and ducts that whisper warmth into cold air. Small mammals, birds, and insects exploit these opportunities. The line between a machine at rest and a habitat in waiting is finer than one might expect. A squirrel nesting near a wiring harness, a rodent chewing through insulation, a wasp building within a pitot tube. Each can alter the subtle aerodynamics and sensor fidelity upon which stable flight depends. The result, when magnified by altitude and velocity, may manifest as turbulence not born of weather, but of mechanical irregularity induced by organic intrusion. Such incidents are not as rare as official reports suggest. Aviation engineers have documented animal-related electrical faults, sensor failures, and airflow disruptions that mimic the effects of atmospheric turbulence. A chewed data line might transmit erratic readings to the flight control system, prompting compensatory movements in stabilizers or engines. To a passenger, the resulting oscillation feels indistinguishable from natural buffeting. The boundary between environmental turbulence and mechanical response thus becomes blurred, one set in motion by the sky, the other by life within the machine. This convergence reflects a broader ecological pattern. As airports expand into semi-rural zones and maintenance facilities border green belts, the interface between wildlife and aviation widens. Rodents, attracted by warmth, insulation, and discarded food, adapt rapidly to hangar environments. So aircraft interiors, especially when set up for cargo or storage, actually offer shelter from predators and the weather. Once these creatures find their way in, getting rid of them isn't really about extermination anymore, but more about constant vigilance. What once seemed pretty improbable, a small mammal affecting flight stability, now stands out as a systemic vulnerability, shaped by proximity and oversight. Meanwhile, the human dimension just adds to the problem. The industry's heavy reliance on automation and predictive diagnostics can sometimes hide the biological factor. Sensors can measure pressure, temperature, and current, but they definitely can't spot teeth marks. Maintenance software can model metal fatigue, but it might completely overlook insulation that's been compromised by organic oils or nesting debris. As data takes over from direct inspection, those subtle traces of infestation might slip by unnoticed, at least until they turn into a bigger failure. What turbulence shows us in this light isn't just the movement of air, but the fragility of our own perception. We end up measuring what we expect to find, not always what's actually there. This synthesis of natural and mechanical disturbance complicates our understanding of flight. Airplanes aren't closed systems, they're porous ecosystems operating at scale. Their interiors host microbes, insects, and, on rare occasions, rodents. Their exteriors accumulate dust, pollen, and organic residue from the skies they traverse. Every component, from winglet to wiring, exists in relation to an environment that includes life. The notion that turbulence could arise in part from this interplay challenges our anthropocentric view of aviation as sterile, predictable, and sealed off from nature. The irony is that such coexistence is neither new nor avoidable. Ships once carried rats across oceans. Aircraft now inherit that lineage in the air. The turbulence we increasingly experience may therefore be read not only as a symptom of changing climate, but as an echo of a deeper, older tension between technology and biology. Machines, no matter how advanced, remain open invitations to life. Each jolt in flight, meteorological or mechanical, reminds us that nature has not been outflown. It rides with us still, unseen in ducts, behind panels, beneath the hum of the cabin, the quiet passenger of every age of travel.